Hi friends, my name is Anil and today we are going to see how we can remove the noise components by passing the given signal through a low pass filter and as well as the high pass filter. Now we have taken the samples and that samples now first the samples we are passing to the high pass filter. Now we created high pass filter using pole zero placement method. Now in the pole zero placement method, by using pole zero placement method, we'll find the transfer function, and by writing transfer function as y by x, and we can easily find the input and output relationship. Now for the high pass filter, we taking the cutoff frequency as point we took the sam we took cutoff frequency as 50 hertz, and the samples is 100 samples per second as the sampling frequency. By doing this, we'll find the r means at what distance the zero is. We will find at what distance the zero is placed and as well as the pole is placed. That from that we will able to calculate the transfer function, and from transfer function we derived the equation of high pass filter as y of n is nothing but 0.9686 into y of n minus 1 plus 0.9843 into x of n minus 0.9843 into x of n minus 1. Now as the loop starts from 1, the initial value 0 is taken as y of 0 is 0.0943 into x of 0. Now we have performed the high pass filter. Now this high pass filter will be acting as an input through the low pass filter. Now for the low pass filter, again we are calculating the transfer function using pole zero placement method. For low pass filter, we have considered the cutoff frequency as 30 Hz and sampling frequency as 100 Hz, and we found out the equation to be y of n is nothing but 0.3719 into x of n plus 0.3717 into x of n minus 1 plus 0.2566 into x of n minus 1. Now this equation for this equation we will consider the input from the high pass filter. Now this is the high pass filter equation for taking cutoff frequency as 30 Hz. Now we will repeat the same again by taking a low pass filter with cutoff frequency as 10 hertz instead of 30 hertz. Now the same process, and now the equation will be modified, and the modified equation will be y of n is nothing but 0.3717 into y of n minus 1 plus 0.31415 into x of n minus 1 plus 0.31415 into x of n. Now again for these two cases also, the initial value is as as the loop starting from 1, the index with minus 1 will already be 0. So neglecting that and taking the initial value as y2 of 0 is nothing but 0.31415 into y of 0. Now again we will consider the same low pass filter with a cutoff frequency as 5 hertz. Initial was 10, previous was 10, and now we are doing with 5 hertz. The same process by using the pole zero placement approach. Now we will calculate the uh, transfer function of the same. Now this transfer function is found to be y of I is nothing but 0.685 into y of I minus 1 plus 0.16 into x of I plus 0.16 into x of I minus 1. Now we will able to plot the diagram. Now we will observe the variations of the output with the input. Now we will just observe the plot of the given input and the high pass filter. Now, so you can see there is no much difference by passing the given signal through the high pass filter. Here it will reach until 1000 because like we have taken 1000 samples. Now we will plot. Now again we'll observe the output at the low pass filter for the cutoff frequency as 30 Hz and the cutoff frequency as 10 Hz. It will take some time. Now you can see This is the output from first low pass filter and the output of the second low pass filter. Now there are again small disturbances, and that disturbances can be removed further by passing the signal through low pass filter with lower cutoff frequency. Now this is the final output from the low pass filter with cutoff frequency as 5 Hz. You can see there are again small disturbances, and those disturbances are neglected if we can pass through still lower cutoff frequency, but this is fine. Now this is how you pass a signal. You will try to remove the noise components by passing a signal through the low pass filter as well as high pass filter. Here I have considered 9600. Now this is the baud rate for the serial communication. Thank you.